Chapter 2, Section 4, Rates of Change and Tangent Lines. This is the last section in Chapter 2. If we have any continuous function, pick a point whose coordinates are x, comma, f of x, because what I mean is the x-coordinate is anything. The y-coordinate would have to be f of x, because anywhere on this function, y is equal to f of x. If I move along the function to another point whose x-coordinate is the x-coordinate in this first point plus delta x meaning some change in x, the y-coordinate would be f of this number so we have 2 points on a function. X, f of x are the coordinates of any point, and these are the coordinates of some other point to the right of the first point. If we connect 2 points on a function with a line, connect 2 points on a function with a line, we call this a secant line. And the slope of this secant line is called the average rate of change. The phrase average rate of change over the interval from x up to x plus delta x. The average rate of change of a function over a given interval means the slope of the secant line. It's the change in y over the change in x. Change in y means we're going to subtract the y's. Whatever y is over here, that's after the comma, minus the y over here, which is after the comma, over the change in x. So the subtraction here at the top is the change in y. In the denominator, we're going to subtract the x's. So I'm going to take x plus delta x minus the x over here, which of course is delta x. So it's f of x plus delta x minus f of x all over delta x. It's just the change in y divided by the change in x. That's what this is. It's the slope of a line. We also call the slope of this line the average rate of change over the given interval. So on page 87, exercise 6, the function of x is 2 plus cosine x. There's actually a typo in the book. That's correct. It should be an x. Part A has the interval 0 to pi. The directions are find the average rate of change of the function over the given interval. Find the average rate of change. That just means the function evaluated at pi, that's the second number in the interval, minus the function evaluated at 0. 0 is the first number in this interval, over pi minus 0. So the numerator is a change in y values. The denominator is a change in x values. And this is what we mean by the average rate of change. F of pi is 2 plus cosine pi, minus f of 0 is 2 plus cosine 0. Using f of x that's given. The cosine of pi is negative 1. And the cosine of 0 is 1. And that's 1 minus 3 over pi. Negative 2 over pi is the answer. We call that number the average rate of change of the given function over the given interval. That's just part A. So average rate of change is the slope of a line. We call it a secant line. If we could make delta x 0, then x plus delta x would be x. So imagine if we could make delta x 0, then x plus delta x would be x. And we would be finding the slope from this point to x plus 0, which means we'd be finding the slope from this point to itself. And that would be when we make delta x 0, which some people would say is impossible because then we would have 0 in the denominator. But we're going to make it possible. So any function, if I want the slope from this point, whose coordinates are x, f of x, same as saying x comma y, the slope from this point to itself, then we'd have, instead of a secant line, we'd have something called a tangent line. Tangent, touching at just that point. The slope of that line is called the instantaneous rate of change. It's the slope of this tangent line. So notice the similarities. In the previous, we said that we connected 2 points. The line was called the secant line. Let's look back. It doesn't matter that it crosses other points along the way. We still call this a secant line. The slope of the secant line is also called the average rate of change. Change in y divided by change in x. The slope of this line, the slope of the tangent line, is called the instantaneous rate of change. Rate of change at this very point, at this very instant. And it is symbolized m subscript t, m for slope, t for tangent line. I'll leave a little space here. It's f of x plus delta x minus f of x all over delta x, just like the just like this, except we're going to make delta x 0. So just where I said leave a space, we're going to write the limit as delta x approaches 0. And this is a really important definition. It's the definition for the slope of the tangent line. It's also the definition for instantaneous rate of change. And the symbols get confusing when we have x and delta x. So from this moment on, we're going to use delta. We're going to use h in place of delta x. We're going to say h approaches 0. The limit is h approaches 0 of f of x plus h minus f of x all over h, where every h means delta x. Hugely important right here. Page 88, number 12. Y equals x squared minus 3x minus 1. We are going to find the slope of the curve. Okay, the phrase slope of the curve and slope of the tangent line mean the same thing. When we have a curve, at any point on the curve, like here, you can make a tangent line. Over here, I can make a different tangent line. Over here, I can make a tangent line. Here, pick any point on the curve, I can make a tangent line. When we say the slope of the curve, we mean the slope of the tangent line at a specific point. So when number 12 says, find the slope of this curve at the indicated point, it really means the slope of the tangent line at x equals 0. First note that when x is 0, y is negative 1. We will use that later. Right now we don't need it. When x is 0, hopefully you see that y will be negative 1. Use that later. So the slope of the curve, also known as the slope of the tangent line, is the definition. It's the limit of f of x plus h minus f of x all over h. H is approaching 0. Looking for the slope of the tangent line at x equals 0 means write this definition. Everywhere we see x, we're going to put 0. The limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. So right here and here, we put 0. This equals the limit of f of h minus f of 0 all over h. The limit of that as h approaches 0. Since f of x is x squared minus 3x minus 1, f of h, that just means h squared minus 3h minus 1. Limit as h approaches 0. Where it says f of h, I'm going to write h squared minus 3h minus 1. Where it says minus, I write minus. Where it says f of 0, I believe we calculated that a couple minutes ago, f of 0 is negative 1. 0 squared minus 3 times 0 minus 1. All over h. This equals the limit as h approaches 0 of h squared minus 3h minus 1 plus 1. Minus at the end becomes plus 1 all over h. That equals the limit as h approaches 0 of h squared minus 3h over h. Because negative 1 plus 1 is 0. This equals the limit as h approaches 0 of h minus 3. Because h squared divided by h is h, and negative 3h over h is negative 3. And this limit, h is approaching 0, is negative 3. That number is the slope of the curve at x equals 0. So what we just calculated at the very beginning here, m subscript t at x equals 0, you could say that's the slope of the tangent line to the curve at x equals 0. So that's the answer to part A. Part B says find the equation of the tangent. A tangent is a line. The equation of a line is always y minus y1 equals m parentheses x minus x1. The x1 was given because it said at x equals 0. M means the slope. That's what we just figured out. And the y1 is the y when x is 0. And x is the number that was given. Y was negative 1. So that's what goes there. The y minus gets copied. The x minus gets copied. And so there it is. That's the equation of the tangent line. It's y plus 1 equals negative 3x. Or y equals negative 3x minus 1. And part C says find an equation of the normal. A normal line is perpendicular to the tangent line at the point of tangency. That means at the point where the tangent line is touching. And perpendicular lines have negative reciprocal slopes. If the slope of the tangent line is negative 3, as we found in part A, the slope of the normal line is the negative reciprocal, meaning it will have the opposite sign and reciprocal. So the equation of the normal, this is the slope, the equation is y minus y1 equals m x minus x1, where this time for the slope we use 1/3. X1 and y1 are the same as in part B, 0 and negative 1. So y minus negative 1 equals the slope times x minus 0, or y equals 1/3 x minus 1. This blue graph is the given function, y equals x squared minus 3x minus 1, blue. This red line is the tangent line, y equals negative 3x minus 1. Tangent, that means it's touching the parabola at 0, 1. And this magenta line, y equals 1/3 x minus 1, is called normal. It's the normal line because it's perpendicular to the tangent. So this would be the answer to part D. So draw the graph of the curve, that's blue, the tangent line, that's red, and the normal line, that's magenta.